everyone, this is your Kalpana. In this video, we are going to prove these 4 trigonometric identities. So these are very important identities. Let's see how to prove this. So first one, prove that secant power 6 theta equals to tan power 6 theta plus 3 tan square theta into secant square theta plus 1. Proof. Since we know that secant square theta minus tan square theta equals to 1. Okay, this is a well-known identity. So now, cubing on both sides, you'll get secant square theta minus tan square theta whole cube equals to 1 cube. So this is of the form a minus b whole cube. Since you know that a minus b whole cube is equals to a cube minus b cube minus 3ab into a minus b. Okay. If in case you are forgetting the formula, then you can just solve this by known formula. So a minus b whole cube can be written as a minus b whole square into a minus b. Okay, we all know a minus b whole square. We'll never forget this, right? So this is equals to a square plus b square minus 2ab into a minus b. So this is equals to a square into a is a cube. Next, a square into b is minus a square b. Next, b square into a plus ab square. B square into minus b is minus b cube. Next, minus 2ab into a is minus 2a square b. Next, minus 2ab minus b is plus 2ab square. 2ab square. So this is equals to a cube minus b cube. Okay. A square b minus a square b minus 2a square b. So you'll get minus 3a square b. Next, ab square plus ab square plus 2ab square. So you're having plus 3ab square. Okay. So now a minus b whole cube is equals to a cube minus b cube. So from these two terms you are having 3ab common. So take minus 3ab common. So you'll get a minus b. See? Minus 3ab into a is minus 3a square b. Again, minus into minus plus. 3ab into b is 3ab square, which remains the same. Okay. So this is a formula. Easy, right? Good. So now this becomes a cube secant square theta whole cube minus b cube tan square theta whole cube minus 3 into a into b, that is secant square theta into tan square theta into a minus b, secant square theta minus tan square theta equals to 1 cube. 1 cube is again 1. Okay. So now this becomes secant square theta whole cube. 2 3s are 6. So you'll get secant power 6 theta minus tan square theta whole cube. 2 3s are 6. So you'll get tan power 6 theta minus 3 secant square theta into tan square theta into 1 equals to 1. Since secant square theta minus tan square theta equals to 1. So you'll replace this with 1. Okay. So now you'll get secant power 6 theta minus tan power 6 theta minus 3 secant square theta into tan square theta into 1 is 3 secant square theta into tan square theta equals to 1. So now you'll take this tan power 6 theta and this term, these two terms to right hand side. Then you'll get secant power 6 theta equals to, since you're having minus, so if you'll take it for RHS, you'll get plus, minus will change to plus. This also, you're having minus, it will take it to right hand side, it will become plus into 3 secant square theta tan square theta. Already you're having plus 1 in the RHS. Okay. So you got the required RHS. So therefore, secant power 6 theta equals to tan power 6 theta plus 3 secant square theta into tan square theta plus 1. So this completes the first identity. Okay. Now coming to second property or second identity, we have to prove that cosecant power 6 theta equals to cot power 6 theta plus 3 cot square theta into cosecant square theta plus 1. Okay. So we know that cosecant square theta minus cot square theta equals to 1. Very familiar identity, right? So this can also be written as cosecant theta whole square minus cot theta whole square equals to 1. Okay. Now cubing on both sides. We get cosecant square theta or cosecant square theta minus cot theta whole square whole cube equals to 1 cube. So this is of the form a minus b whole cube. Since we know that a minus b whole cube is equals to a cube minus b cube minus 3ab into a minus b. So now we can utilize this formula. So this implies a cube cosecant theta whole square whole cube minus b cube cosec cot theta whole square whole cube minus 3ab minus 3 into cosecant theta whole square can be written as cosecant square theta into cot theta whole square can be written as cot square theta into a minus b. A is cosecant square theta minus b is cot square theta, which is equals to 1 cube. 1 cube is 1. So this implies cosecant theta whole square whole cube. So 2 3s are 6. So you will get cosecant power 6 theta or cosecant theta whole power 6 minus cot theta whole square whole cube. So 2 3s are 6. So you will get cot theta whole power 6 minus 3 cosecant square theta into cot square theta into 1 equals to 1. So we have replaced cosecant square theta minus cot square theta with 1. Okay, since cosecant square theta minus cot square theta equals to 1. So we have replaced cosecant square theta minus cot square theta with 1. So this implies cosecant cos 6 theta minus cot cos 6 theta minus 3 cosecant square theta into cot square theta equals to 1. Okay. So now we are going to take these two terms to right hand side. So this implies cosecant cos 6 theta equals to minus. If you take this minus cot cos 6 theta to right hand side, you will get plus cot cos 6 theta. Minus becomes plus. And the second term, third term also. Minus becomes plus 3 cosecant square theta into cot square theta. Already you are having 1 in RHS. So you will add 1. So this completes the second one. Second identity. Therefore, cosecant cos 6 theta equals to cot cos 6 theta plus 3 cot square theta into cosecant square theta plus 1. So this completes the second identity. Okay. Next, coming to third one. Third property. Third identity, sorry. 1 plus, prove that 1 plus tan square theta into cot theta by cosecant square theta equals to tan theta. Prove. Now consider the LHS part. 1 plus tan square theta into cot theta by cosecant square theta. Okay. Since you know that 1 plus tan square theta is equals to secant square theta. So now you will replace 1 plus tan square theta with secant square theta into cot theta by cosecant square theta. Okay. Since we know that Reciprocal of cos theta is equals to secant theta. If you square on both sides, you'll get 1 by cos square theta is equals to secant square theta. So this is equals to, now replace secant square theta with 1 by cos square theta. And also you know that cot theta is equals to cos theta by sin theta. So now replace cot theta with cos theta by sin theta divided by, we know that cosecant theta is equals to reciprocal of sin theta. So if you square on both sides, you'll get cosecant square theta is equals to 1 by sin square theta. Okay. Now replace cosecant square theta with 1 by sin square theta. Fine. So this equals to cos theta into 1 is cos theta divided by cos square theta into sin theta is cos theta whole square into sin theta divided by, or we can write it as into sin square theta by 1. Okay. So sin square theta can be written as sin theta whole square, which can also be written as sin theta into sin theta, and here cos theta whole square can be written as cos theta into cos theta. Okay, just for our convenience. Okay, so cos theta gets cancelled. So this is equals to sin theta into sin theta divided by cos theta into sin theta. Again, sin theta gets cancelled, so finally you'll get sin theta by cos theta, since tan theta equals to sin theta by cos theta. So this is equals to tan theta is a RHS. Okay. So therefore, therefore 1 plus tan square theta into cot theta divided by cosecant square theta is equals to tan theta. So this completes the third property. Now let's see for fourth property. Fourth one, prove that 1 plus cos A divided by sin square A equals to 1 by 1 minus cos A. Okay. So if you'll notice, in the first term you are having numerator 1 minus cos A. In the first term, in the sense, the LHS part. So you are having 1 plus cos A in the numerator, and in the RHS part you are having 1 minus cos A in the denominator. To get 1 minus cos A in the denominator, we have to rationalize the numerator in the LHS part. Proof. So consider the LHS part. 1 plus cos A by sin A. Now what we are going to do? We are going to rationalize the numerator. So this is equals to 1 plus cos A by sin square A into 1 minus cos A by 1 minus cos A. Okay. Okay, so this is equals to 1 plus cos A into 1 minus cos A divided by sin square A into 1 minus cos A. Okay, so in the numerator you are having two terms, A plus 1 plus cos A into 1 minus cos A, which is of the form A plus B into A minus B. Since A plus B into A minus B is equals to A square minus B square. So you'll get 1 square minus cos A whole square divided by sin square A into 1 minus cos A. Denominator remains the same. Okay. So this equals to 1 square is 1 minus cos A whole square can be written as cos square A divided by sin square A into 1 minus cos A. Since you know that sin square theta plus cos square theta is equals to 1. Okay. If you take this cos square theta to right hand side, you'll get sin square theta equals to 1 minus cos square theta. Okay. So now you can replace 1 minus cos square A with sin square A. So this equals to sin square A by sin square A into 1 minus cos A. Okay. So now in the numerator you are having sin square A and in the denominator also you are having sin square A. So you can cancel these two. So finally you'll get 1 by 1 minus cos A, which is your RHS. Okay. So therefore 1 plus cos A by sin square A equals to 1 by 1 minus cos A. This completes the identity. This is all for now. Hope you will understand. If you have any doubts, just leave your comments below. See you in the next video. Until then, bye bye.